Hello everyone, welcome back to Study Seekers, and in today's video we are going to learn about one of the most important topics in operation research, the transportation problem. And I'm going to explain it in a very simple and practical way. Basically, this concept is used when we need to transport goods from different places to different destinations in the most efficient way, especially by minimizing the cost. So we'll understand what a transportation problem is, and then we will look into different methods that is used to solve it, like northwest corner method, and then least cost method, and then the VAM method. So let's get started and understand this step by step. So let us understand this definition step by step. A transportation problem is a special type of linear programming problem. Here, special type means it is not completely a new concept. It is actually a part of linear programming, and but it is only focused only on the transportation situations, and then where we have to transport goods from different sources to different destinations. This means we are dealing with movements of products like raw materials and finished goods from one place to another. Sources are the places where goods are available. For example, factories or warehouses. Each source has a certain supply to different destinations. Destinations are the places where the goods are needed, like shops or markets, and each destination has a certain kind of demand. So, in the most efficient way. So, overall, a transportation problem helps us to decide how to move goods from sources to destinations in such a way that everything is satisfied and the cost is as low as possible. For example, imagine there are two factories and three shops. So each factory has a certain number of goods available, and each shop has a certain demand that needs to be fulfilled. Also, the cost of transporting goods from each factory to each shop is different. Now, the question is, how should we transport goods from these factories to the shops so that all the demands are satisfied and the total cost is minimum? This is exactly what a transportation problem helps us to solve. So, in simple words, a transportation problem is about finding the most efficient way to distribute the goods from sources to destinations while minimizing the total cost. So, now that we have understood what a transportation problem is, let's move one step ahead and see its types and how we actually solve it. First, transportation problems are mainly of two types. They are balanced and unbalanced. So these are the two types of transportation problem, and a transportation problem is said to be balanced when the total supply from all the sources is exactly equal to the total demand at all the destinations. So the total supply must be equal to the total demand. At that time, it is said to be a balanced transportation problem, and in simple words, whatever the goods we have available can exactly satisfy all the requirements, no extra or no shortage. So, on the other hand, if the total supply is not equal to the total demand, then it is called as unbalanced transportation problem. In such cases, we simply add a dummy row. We simply add a dummy row or a column to balance the problem so that we can apply the standard methods. Because when the problem becomes unbalanced, we cannot proceed further to solve that problem. So now once the problem is ready to solve, it is done in two main stages. The first stage So the first stage is finding the initial basic feasible solution. So this is going to be our first step. This means we start with an initial way of distributing the goods such a way that all the supply and demand conditions are satisfied. We are not focusing on the best solution yet, just a valid starting point. There are different methods to find this initial solution, such as the northwest corner method, least cost method, and then the Vogel's approximation method. After finding this initial solution, we move to the second stage, which is finding the optimal solution. The step 2 is the second step is finding the optimal solution. Here we check whether our current solution gives the minimum transportation cost or not. If not, we improve the solution by step by step until we reach the best possible result. So overall, solving a transportation problem is a two-step process. First, find a initial basic feasible solution and then improving it to get the optimal solution. Okay, so now that we understand the types of transportation problems and the overall steps that is involved, let us start solving it using different methods. So the first method that we are going to learn is the northwest corner method, and this is the simplest method that is used to find the initial basic feasible solution. So in this method, we basically start from the top left corner of the transportation table, which is called the northwest corner, and begin allocating the values the step by step. So the main idea of northwest corner method is to satisfy the supply and demand one by one by moving either right or down in the table. So let us understand this with an example. Okay, so this is the question that we have, and firstly what we need to look into is the supply and demand should be equal. So the total supply here is, this is the supply, that is 4 plus 8 plus 9, which is 21, and then the demand will be this thing, that is 3 plus 3 plus 4 plus 5 plus 6. Add all of this and then we'll get 21. So since the supply and demand are both same, they both are same, it is therefore a balanced problem. So we can move on further and solve it with the northwest corner method. Okay, so we need to draw a table like this for solving the northwest corner. Before we start solving, let us understand what exactly the northwest corner means. If you look at a transportation table, to the top left cell is called the northwest corner, and why northwest is because like directions on the map, top represents the north and the left represents the west. So the top left position becomes the northwest corner. And now why do we start allocating from this corner itself? The main idea of northwest corner method is very simple. We start from the first available cell and then begin allocating values without worrying about the cost. We take the minimum supply and demand in that cell, assign that value, and then move step by step either to the right or downward. This method does not try to give the best or lowest cost solution. Instead, it gives us a basic starting solution that satisfies the supply and demand conditions. So in short, this northwest corner is just the starting point, and this method is used to quickly find a feasible solution, not necessarily the optimal one. So let us start solving it. Since I've said that this particular cell is the northwest corner in this table, we start assigning the values to it. Let's see what is the demand and supply. We just write the demand and supply that is given over here: 3, 3, 4, 5 and 6, and then in the supply 4, 8 and 9. So yeah, here we can see that the supply is 4 and the demand is only 3. So what happens here is we will allocate 3 here and then we cancel out it and make it 0. We cancel out this and make it 1 because 3 demand is satisfied and 1 supply has been left out. And then since here we have got 0, we'll just strike out this particular column. Then we'll move on to the next northwest corner. The next northwest corner is this one, and then we'll check the demand and supply over here, where the supply is 1 and then the demand is 3. So whichever is the less number, that will only get allocated, and then here it is becoming 0, here it will become 2. So yeah, and then since it has become 0 here, this row gets striked out. So and then the next northwest corner that we have is this. The demand is lesser than the supply, so if we'll just allocate 2 over here and then here it becomes 6. Okay, and then since we have got 0 here, we are just gonna strike out this cell, and then the next northwest corner that we have is this one. And yeah, please also remember to write the cells numbers that is there in the question. We must also remember to write the cells numbers as given in the question. So yeah, now we'll start solving again. So after meeting the demand here, this cell gets striked out because it has gotten 0 here, and then we are left with more 6 supply units. Now the next northwest corner is this one, so we'll try to allocate here where the 4 is the smallest number and this gets striked out, and 4 demand is met, and then this particular column will get striked out. Here instead of 6 there will be only 2. And now let's move on to another northwest cell, that is this one. So here we have 2 supply and then 3 demand. So this particular row gets cancelled, and then the next northwest corner that we have is this one. So the demand is 3 and supply is 9, and now we have 6 supply left. And the next northwest corner is this one. We just allocate 6, which becomes 0 on both sides, and now if it is balanced we get 0. We get 0 everywhere, and if it is not, we will not get the zeros here. That means it is an unbalanced problem. So now before finalizing our solution, there is one important condition that there's one important condition that uh, we need to check, that is m plus n minus 1. Here m represents the number of rows, which means the number of sources, and then the n represents the number of columns, which means the number of destinations. So now we calculate m plus n minus 1 and then compare it with the number of allocations that we have made. But what do we mean by the allocations? Allocations are simply the number of cells that we have assigned values to, like this. And then while solving the transportation problem, we would have assigned some values to the cells. Now why do we actually check this condition? Why is it so important? This is done to make sure that our solution is very valid, basic, feasible solution. If the number of allocations is exactly equal to m plus n minus 1, then the solution is called as a non-degenerative solution. So it is called as a non-degenerative solution. And this means that everything is perfectly structured and we can directly move forward. But if the number of allocations is less than m plus n minus 1, then it is called as a degenerate solution. In this case, we need to make a small adjustment by adding a very small value, usually represented by the epsilon. Yeah, this kind of a value is used. We'll see that in the other problems where this kind of condition occurs. And to one of the empty cells, just to balance solution, we use the epsilon. And so in short, this step is just a final check to confirm that our solution is properly formed, ready for further optimization. So as I said before, let us just check whether that important condition is being satisfied here or not. That if m plus n minus 1 is equal to number of allocations. So here the m is the number of sources, that is we have three sources here, that will be 3, plus n is the number of destinations that we have, that is 5 destinations. 5 minus 1, so 3 plus 5 minus 1 is 7, and the number of allocations that were made in the problem is 1 2 3 4 5 6 and 7. So m plus n minus 1 is equal to the number of allocations, and it is hence therefore it is non-degenerative. So we will now calculate the final solution, where we need to just multiply the allocated cell number and then this number and add all of them accordingly. Like for example, 3 into 2 for this cell plus 11 into 1 plus 4 into 2 plus 4 into 7 plus 2 into 2. Keep on multiplying 6 into 6 is 6 into 6. So we'll solve this one by one. 6, 3 twos are 6 plus 11 plus 8 plus 4 7 is a 28 plus 2 twos are 4 plus 24 plus 6 6 are 36, and then our final solution is going to be 117 is going to be our answer. So yeah, that's how the northwest corner method is solved. Okay, so now let's move on to the next method, which is the least cost method. And the method is this method is used to find an initial basic feasible solution, just like the northwest corner method. But the major difference is here we consider the transportation cost. Instead of starting from the top left corner, we look at the entire table and select the cell with the least cost. And let us understand this step by step using an example. First, we check whether the problem is balanced or not. So let's take the total supply first. The total supply is 30 plus 50 plus 20, which is 100. And then the total demand is 20 plus 40 plus 30 plus 10, which is also 100. Yeah, so we can now say that it is a balance problem, since the total supply is equal to the total demand. So therefore it is balanced. Since both are equal, the problem is balanced. Now we begin the least cost method. So now we have the table ready. We just need to fill in the values like this: 4, 2, 5 and 9. Also write the demand and supply accordingly: 40, 30 and 10. So what we should do here now is find the least cost cell. Among these, 1 is the most least cost cell. Since there are 3 cells containing 1, I'm going to choose the first one. So if I choose this one, I'm going to allocate based on the demand and supply. So 20 is lesser than 30, so we can meet this demand. And now we have supply 10 and demand 0. We're gonna strike out this particular and then let's move on to the next cell, next least cost cell, that is this one. We have 30 here and then 10 here. I'm going to allocate 10 and here we'll be left with the 20. Since we have 0 here, we're going to strike out this particular thing. And next, the next least cost cell is this one, and I'm going to allocate 10 over here since this is less than the demand. Now we have 40 here and 0. We can strike out this. And next least cost is 2. Since I have a tie, I'm going to choose this one for allocation. So we have 20 here and 40 here. I'm gonna assign 20. So after assigning 20, the next least cost that I have here is the 2. Let's allocate here now. 20 is less than 40, so I'm gonna allocate 20 over here. This becomes 0 and here this becomes 20. This particular source 3 is going to get cancelled. The next least cost that we are left with is this cell, and also this is the only cell that we're left with. So I'm just going to allocate 20 here, which on the both sides it is going to be 0. So after this much, we must write the transportation schedule. This is how it is written. The transportation schedule: S1 to D1, which means this is the first cell that we choose to allocate, so that is S1 to D1. And then secondly, that is S1 to D3. The second cell that we choose to allocate is this one, S1 to D3. And then the third one is S2 to D4. We must keep track of this while solving the sum as well. The third cell that we took is the S2 to D4 because this was the third least cost cell, and the fourth one is S2 to D3 yeah, this one. S3 to D2, it is S3 to D2, and lastly S2 to D2, this one. So this is this transportation schedule, and then we must also write the transportation cost. Transportation cost will be 20 into 1, this one, 20 into 1, and then plus 10 into 1 plus 20 into 3, this one, plus 20 into 2 plus 10 into 1 plus 20 into 2. So this is going to give us 20 plus 10 plus 60 plus 40 plus 10 plus 40. The finally 180. So that was all about the least cost method. And unlike northwest corner method, here we consider the cost. So this is usually, like, this method gives us usually a better initial solution compared to the northwest corner. Now let us see how the uh, Vogel's approximation method works. Move on to the Vogel's approximation method, and which is also called as VAM. This method is used to find a better initial solution compared to the northwest corner method as well as the least cost method. So in the northwest corner method, we do not consider the cost at all. And in the least cost method, we only pick the smallest cost directly. As we can see here, we had to pick the uh, least cost directly. Approximation method, we can go one step ahead. Here, instead of just looking at the smallest cost, we calculate something called as the penalty. Okay, penalty means the difference. It's the difference between the two smallest costs in each row and each column. We this actually helps us to understand where we are making a wrong choice and would increase the cost the most. So VAM helps us to make a smarter decision while allocating the values. Now let us solve the problem step by step. First, we check whether the problem is balanced or not, as usual. So the total supply here is 30 plus 50 plus 20, that is 100. And then the total demand, 20 plus 40 plus 30 plus 10, which is also 100. Since both are equal, the problem is balanced. Since the supply and demand both are equal, therefore the problem is balanced. And now we start calculating the penalties. For each row and for each column, we find the two smallest values and take their difference. So let's solve it. Okay, we need to draw the boxes like this, and then now we start solving it by looking at the difference in each row and column. Here, the least cells are this and this, and if we take the difference of it, we'll get 0. And the same way, we should also do it for this one, where the least cost cells are these two. When we take the difference of them, we'll get 2, and we just gonna write it under that particular row or column. And then we should do the same thing with this as well. 2 minus 1 will be 1, and then here it will be 2, because 4 minus 2 is 2. And then here also it's going to be 0, 1 and 3. Okay, so in among all these numbers, we must find out the highest number, which is going to be 3 in this case. And from here, we need to start solving, like allocating the numbers into the cell. In this particular column, after we find out the highest value, we should find the lowest value in this column, that is 1. Here we will allocate 10 because the demand is lesser than the supply. So now we'll allocate it, the 10 here, and here it becomes 0. Now here it becomes 40. Okay, and then do the same thing after getting 0 here. Just strike out these particular cells from that column. So we will do the same procedure now also. Since this particular thing has been striked out, we will just put a dash over here, because further we are not going to find any difference from this particular column. Okay, so the next thing is find the differences again. Here again it is going to be the same and same. Here also it is going to be 0, 1, 2. So now we must find out the highest number. Since we have a tie 2 and 2, I'm going to choose this one. We can also choose this one. It's up to us. So now after choosing this, we must find the least cost cell in this particular column, which is going to be this one. I'll allocate here 20, and this becomes 0. This will become 10, and accordingly this column is going to be striked out. In the next further calculations, we are not going to find any difference from this particular column. After that, we are going to find the difference again. Here it is 1. It's going to be 1. Here it is going to be 1, and here it's going to be 3, and here it's going to be 0. Here 1, here again dash. So if we see, the highest number here we've got is 3, and after getting this one, we must find the least cost cell, which is going to be 2 here, and we will allocate 20 because that is the less number. Here we'll get 0. Since we have got 0 here, this is going to get striked out. So the next thing is, again we're going to find the differences. This is going to be nothing, and then here 1, because 3 minus 2 is 1, and here it is 1 again because 2 minus 1 is 1. Here nothing, and from here 1 and 1, because 2 minus 1 and 3 minus 2 is going to be 1. Here, since we have a tie, I'm going to choose this one. So here in this particular column, the least cost is this one. I am going to allocate here. Since I have 10 less number in the supply thing, I'll take that and allocate here the 10. So we are going to find the difference again. Yeah, here I am getting, since only one particular cell is left, I am going to just put 3 here because of the number, and then here we'll get and for here we will get, since we have got 0 here, we are going to strike out this particular row, and this row is not going to be considered to find the difference. Now since we have only this one cell left, I'm going to take 2 here as well, and here it is nothing as usual. Here also, since got uh, this got over completely, this is a dash, and here it is 1, and then here it is okay dash. So this much is done. Now we are going to allocate again. Since the least cost cell that I have now is this one, I'm going to allocate 30 over here. Since this is the smallest number, this will get 0, and we will still have 10 left. I've allocated 30 here, and then we have one more cell left. Here I'm going to allocate 10 because we have that much of supply and demand left. So this is how basically the Vogel's approximation method is done. And now we will calculate the transportation cost. Okay, lastly the transportation cost. 20 into 1 plus 10 into 2 plus 10 into 3 plus 30 into 2 plus 10 into 1 plus 20 into 2 give us 180. So that is the answer. In summary, Vogel's approximation method works by calculating the penalties and marking smarter allocation choices, which usually gives us a better initial solution compared to other methods.